Hi students, welcome back to this tutorial. From this video onwards, we can start learning binary arithmetics. And in this video, we can discuss the addition and subtraction of binary numbers. So we can start with addition. For adding numbers, the procedure we need to follow is the same procedure which is used for adding decimal numbers. Okay, so just go through the addition of decimal number first, then just understand the procedure using that. And after that, we can apply the same procedure for adding binary numbers also. Okay, so this is two decimal numbers, 960, 172. We need to add these decimal numbers. What we want to do, we need to add numbers correspondingly, and the addition start from our right hand side and move or proceed towards left hand side. Okay, so while adding these two numbers or these two digits, 0 plus 2 is 2. Okay, next 6 plus 7. So while adding the 6 and 7, we get a number 13. But in decimal system, we have only these much digits in which 13 is not present. Okay, so while adding this 6 and 7, we get a result 13, right? But we can't place 13 as it is here. What we want to do in this situation, place this unit value 3 here and pass this value present in the 10th position as a carry to the next level, like this. Okay, here while adding 6 and 7, we get a value 13. This 13 is not present in the range of decimal system. So, in that case, place the unit value here and pass the value present in 10th position as a carry to the next level. Right, so now we can add these three numbers together like this. 1 plus 9 plus 1. 1 plus 9 plus 1, which is 11 again is not present in this decimal system range. So what we want to do then, place the unit value, that is this 1 here, and pass this 1 to the carry. Pass this 1 as a carry to next level. But here we have no digit left here for adding with this carry value 1. So in that situation, we can directly write this value here. So this is the result of adding these two decimal numbers. Okay, so just understand this procedure. Now we can apply the same procedure for adding binary numbers also. Okay, so for binary numbers, the base is 2 and the possible values are 0 and 1. Okay, so here it is the table which shows the rule for adding binary numbers. So if the corresponding bits are like 0 and 0, the sum value is 0 and the carry is 0. And the bit 1 is 0 and bit 2 is 1. Then the sum is 1 and carry is 0. While adding 0 with 1, we get sum 1 and with no carry. Okay. So while adding 1 with 0, we get the sum value 1 and carry 0. Again, while adding two ones, what happened? 1 plus 1 is actually, in decimal, 1 plus 1 is actually 2. Okay, but 2 is not present in this range of binary, right? So we can't directly represent 2 in some field. 2 can be represented in binary like 1, 0. So the unit value 0 is present in some position and the 10th position value, that is 1. 1 is passed as a carry to the next level. That is why while adding 1 and 1, we get some position with value 0 and carry as 1. So consider some examples. So here we have two binary numbers. Okay, consider the addition. Proceed from RHS towards LHS. LSB position to MSB position. Okay, so while adding this 0 and 1, 0 and 1 is sum is 1 with carry 0. Okay, if the carry is 0, no confusion, add these two numbers together. 1 and 1, the sum 1 and 1 means 0 with carry 1. Or in other ways, in decimal, while adding 1 and 1, we get value 2. The 2 in binary is 1, 0. Right? So this unit position value, this 0 is placed here in this sum position, and this 1 is passed as a carry to next level. Okay, we can follow this or we can consider this. Okay, next is 1 plus 1 plus 1. So the simple method is, while adding 1 plus 1 plus 1 in decimal, we get 3. 3 in binary is 1, 1. So this 1 is placed here as the sum value, and this 1 is passed as a carry to next level. Okay, now we can add this 1 and 0. While adding 1 and 0, we get sum with no carry. Okay, so here we have no other value for adding with this one, so 1 is directly put down here. So this is the final result of this addition. Okay, now we can consider one more example. So while adding this 1 and 1, we get 1 and 1 means in decimal, while adding 2 ones, we get 2. 2 in binary is 1, 0. So this unit 0 is placed in the sum position, and this 1 is passed as a carry to next level. Okay, so this 1 plus 0 is 1. 1 plus 0 is 1. That one again added with this 0 is 1 with no carry. Right? 1 plus 0, sum is 1 with no carry. So again adding this 1 and 1, we get, in decimal we get 2. The binary equivalent is 1, 0, right? So place this 0 here in this sum position, and this 1 is passed as a carry to next level. So this 1 and 1 we want to add next. 1 and 1 is 2, right? The 2 is added with this 0. 2 in binary is 1, 0. So this 0 is placed here, and this 1 is passed as a carry to next level. Again 1 plus 1 is 2. 2 plus 1 is 3. 3 in binary is 1, 1. So this 1 is placed here, and this 1 is passed as a carry to next level. Okay, so here 1 plus 0 is 1. Again that 1 plus 0 is 1 with no carry. Okay, here 1 plus 1 is 2. 2 in binary is 1, 0. The 0 is placed here, and this one is passed as a carry to next level. But here we have no other bits remaining here for adding with that carry. That means here we can assume here it is present 0 and 0. So the carry value 1 is added with this 0 and 0. So the result is, or the sum is 1. So this is the final result of this addition. Okay. So next is the subtraction. For getting the idea of binary subtraction, we need to understand the procedure that is following for subtracting decimal numbers. Okay. So follow this procedure. Here 973 minus 544 in decimal. Okay. So while subtracting 3 minus 4. Okay. So in this case, 3 minus 4, we can't directly subtract 4 from 3. So in that case, we need to borrow from the next position to this position, and this 3 become 13 now. Right? We need to borrow 1, and here it become 10 plus this 3, that is 13. From this 13, we can subtract this 4. Okay, and also while giving one borrow value to this position, this 7 become 6. Right, so this 13 minus 4 is 9. So while passing one value as a borrow to this position, here the 7 become 6. So 6 minus 4 is, what is 2. Okay, next is 9 minus 5. 9 minus 5 is a direct subtraction. We get a value 4. So after this subtraction, the result is 429. Okay, so this is the procedure. For subtraction, sometimes we need to borrow from the neighbor. Okay, so consider one more example for subtraction in decimal. Here the number, the first digit here it is 1 and 9. That means we want to subtract 9 from 1. This is not possible directly. So in that case we need to borrow from the neighbor. But here the neighbor is 0. We can't borrow anything from 0. So we need to check the next neighbor. This position. Here also it is 0. We can't borrow anything. So move to the next position. Here it is a non-zero value 9. So we can borrow from here. So what happened? While borrowing value from this position, this become 8 and this become, the borrowed 1 become 10. 10 plus this 0 is 10 only. Okay. Now here we have non-zero value 10. From this 10 we can borrow to this location. While borrowing one value from this location to this, here it become 9 and here it is, the borrowed 1 is 10. The borrowed 1 become 10. Okay. 10 plus this 0 is 10 only. Now here in this position we have non-zero value. From this value we can pass one value to this location. While passing, here it become 9 and the past value here it is taken as 10. That 10 plus this 1 is what? 11. So from this level we can subtract 9 directly. So while subtracting 9 from this level, here it is 2. Now here the position value is 9. 9 minus 8 is 1 and here it is 9. 9 minus 5 is 4 and here it is 8 only. Here we have no other digit left here for subtracting from this 8. So we can directly put this 8 down here. Okay, so this is the final result of subtraction. Okay, so consider the binary subtraction, binary with only these two values in the range of binary system, zeros and 1, and the base is 2. Okay, so consider one subtraction. 1, 1, 1 subtracted by 1, 1, 0. Okay, for subtracting this, we can consider this particular table. By subtracting this 0 from this 0, the result is 0. And 1 minus 0 is 1 itself. And 1 minus 1 is 0 with no confusion. Okay, but here, this is the only one case which generate confusion, that is subtracting 1 from 0. 0 minus 1. In this case, we want to borrow from the neighbor. And the result is always 1. Okay, this will become clear with some examples. So consider this subtraction. 1 minus 0 is 1 minus 0 is 1. Subtracting 0 from 1. No change. The result is 1. Subtracting 1 from 1. 1 minus 1 is 0. Subtracting 1 from 1, that is 1 minus 1 is again 0. Okay, so now we can check whether the result is correct or not. How? This 111 in decimal is 7. This 110 in decimal is 6. 7 minus 6 is 1. The binary equivalent of this 1 is 1 itself. That is 0, 0, 1. Okay, so the result is correct. Okay, consider this example. Here the numbers are 110 minus 001. So while subtracting, here it is 0 minus 1. This is the case of borrowing from neighbor. So while borrowing from this position, what happened? This 1 become, we need to pass one value from this to this location. So this 1 become 0. 1 minus 1 become 0. And this position become 2. Why? Because the positional value, now it is the borrowed 1 into 2 to the power 1 plus the value present here it is 0. 0 into 2 to the power 0. That is 2 plus 0 is 2 in decimal. The binary equivalent of this 2 is 1 0. Okay, that is why 1 0 here. The borrowed value from this location is represented like this: 1 into 2 to the power 1 plus the value present here, it is 0 into 2 to the power 0. So 2 plus 0 is 2. 2 in binary is 1 0. Right? So the 2 minus 1 is 1 here. So after passing one value to this location, now here the value 0. Now 0 minus 0 is 0. Here 1 minus 0 is 0. Sorry, 1 minus 0 is 1. Okay. So this one is actually 6 in decimal, 110. And 001 is 1 in decimal. 6 minus 1 is 5. So the answer is, this one is actually binary equivalent of decimal 5. The answer is correct. Okay. Okay. Consider one more example. So here is the number 10010 minus 111. So here, while subtracting 1 from this 0, we need to borrow from neighbor. Okay. Borrow value from this location to this. So here it become 1 minus 1, 0. And here it become 10. 10 means 2 in decimal. Okay. So 2 minus 1 is 1 here. And here it is the value 0 now in this position. From this 0, we can directly subtract this 1. So what we want to do? We want to borrow from neighbors. But in this neighbor, here the value is 0. We can't borrow anything from the 0. So check the next location. But here also it is 0. We can't borrow anything from the 0. So move to next neighbor. Okay. Here it is non-zero value 1. So what we want to do in this case? So in this case, we can transfer one value from this location to this as a borrow. So while doing that, this 1 become 1 minus 1, 0. And this location is 2 now. That is the borrowed 1. 1 into 2 to the power 1 plus this 0 into 2 to the power 0. That is 2. 2 in binary is represented as 1 0. Okay. Now here this location contains non-zero value 2. From this 2 we can transfer one value to this location. Okay. So here it become 1. 2 is subtracted by 1. 1 is passed to this location. So this 2 become 1 and this location now contains 2. Now this location contains non-zero value 2. So we can transfer one value to this location as a borrow. So this 2 become 1 and this location contains 2. Okay. So 2 minus 1 is 1 now. Okay. Then here it is 1 now. 1 minus 1 is 0. And here it is 1. And from this 1 we have no value to subtract here. So we can directly put this 1 here. Or we can assume here it is 0. 1 minus 0 is 1. Again here we have the left value is 0. And here we have no other value. And we can directly put the 0 here. So this is the result of our subtraction. 0 1 0 1 1. Okay. Thank you.